Hey guys, welcome back. We're working on our quadratic forms worksheet for today. Make sure you have your either quadratic forms memorized or you have your reference sheet handy. Okay, so we need to know all the four quadratic forms that we're going to be dealing with. It's standard form, intercept or factored form. Oh, sorry, standard form, work line, quadratic form, vertex form, and focal form. So these are the four that we talked about earlier this week. So this is kind of my reference sheet that helps me figure out, what all the pieces do and how do I get from one form to the other and what do the forms look like. So in the last video I did number 2 for you, and then I actually did 2 from the next set just because these ones can be a little bit tricky, and it's been a little bit since we've done something like this. So 5 and 6, again, we walked through for you if you need that. So we're going to jump to the next page here, and I'm just going to kind of keep following that same pattern. I'm going to do one of the evens, since you don't have the answers to check. I'll leave you 2 of the odds that you can do and check, and then I want to leave you one that doesn't have an answer so that I can kind of assess and see how you guys are doing on your own. So let's look at number 10 here, and then you guys will have an example for these other 3. Okay, so we want to put our equation in focal form, and then find the vertex and direction the parabola opens. So what is focal form? It's this kind of stuff, right? We want it to look like one of these. Okay. Once we have it in that form, we can figure out what the vertex is, because the vertex is going to come from the numbers inside here. And the direction will depend on which variable is getting squared and if we have a negative out in front here. Okay. So let's jump into number 10 real quick. The first thing we want to do, and again, we've done these before as well, so this isn't brand new for you. This should be something that you've already done before, but I want to give you a little reminder. The first thing we do is identify which variable is squared, right? And in this case, it's x squared. Some of these it'll be y, like these 2 down here. We're going to have a y squared, so just keep that in mind. It could be a y squared. The next thing you need to do is you need to get everything that doesn't have an x onto the other side, kind of similar to what we did in the last problem set. So we're going to get rid of the 2y and the minus 2 here. So I'm going to minus 2y from this side and then plus 2 on this side. I got to do the same thing on the right hand side. Minus 2y and then plus 2. So these are gone. My next statement then, the next line would be x squared minus 4x. I'm going to leave a space here for to complete the square. Equals negative 2y. Whoops, this should be a plus 2. Plus 2. Alright, so now we just got to complete the square. We got to figure out what number goes here. And to do that, we take the middle term, the b term, divide it by 2, and then square it. So negative 4 divided by 2 would be negative 2. And then we take negative 2 and we square it. So negative 2 squared, if we want to square negative 2, is going to give us a positive 4. Okay. And then we have to add 4 on this side as well. Okay, so the next line then would be x squared minus 4x plus 4 equals negative 2y plus 6, because I combine those 2 like terms. And then the whole point of completing the square, every time we complete the square, the point is to be able to write it as some binomial squared. And if we look at our standard form, or excuse me, our focal form, yeah, we want some binomial squared. That's what we're looking for. So that's the whole point. So what number goes here? It's half of this b, right? Negative 4 divided by 2 is negative 2. Okay, so the relationship here is this number divided by 2 gives you what goes in there. If you square that number, you end up getting the number that goes here. So that's the relationship between those 3 numbers. Okay, do that line there. All right, so that's what we got going on the left. On the right, what we're going to do is we're also going to factor this, but we're going to factor it a little bit differently, because this is not a perfect squares trinomial, but it does have a common factor. So we got to find out what the common factor is here between these 2 terms, and they both have a 2 in it. And since there's a negative in front, we want to factor out a negative 2. Okay. What we want in parentheses at this point is we just want something like this. We want just a plain y at the very beginning of our parentheses term, and then maybe a number with it. So we've got to get that negative 2 kind of outside some parentheses. So I'm going to factor out a negative 2. And what's left then is just the plain old y, which is what I wanted. And then the number that goes here is got to be a -3, because -2 times -3 gives me my +6. So -2 times y gives me -2y. Okay, check. -2 times -3 gives me 6. Awesome. So this is it. This is my focal form. That's what we wanted. Okay, now the other thing we've got to do is find the vertex. Okay, well the vertex is going to be +2, +3, right? We're going to take the opposite kind of the numbers that are in here. So the vertex is 2, 3. Okay, and the direction. Since x is being squared, we have an x squared on the left-hand side. This parabola is going to be a vertical parabola, which means it either opens up or down. That's your options for x squared. If it's a y squared parabola like this guy or this guy, it's going to open left or right. And then how we tell which of those directions is we look at the negative as well. So the x is being squared in this case, so it's up or down. Since I have a negative out here, that means it's the negative version. That means this guy's going down. Oops. Okay. So that's, again, something that we've already done before. We did that, I think, last week sometime. But we're just putting it all together now. We're taking all the different forms that we had. We're going back through them. We're reviewing what the purpose for each form is. So we've done this recently. The last problems that we did, the vertex form, it's been a while for that. And it's been a while since we factored something in quadratic form. So just putting it all together in this assignment. Okay. The next one we're going to do here is we're going to do number 14. Okay. So in this equation here, we have already in focal form, and we want to find the focus and the equation of the directrix. So when it says equation of the directrix, remember, is a line. And so when we find the equation of the directrix, it's either going to go left or right, or vertical or horizontal. So it'll be like an x equals or a y equals equation. So what I'm going to do on this one is I'm actually going to have a little bit of a scratch paper that I'm going to write on so that I can get an idea of how this graph is going to look. It's hard to do this problem unless you kind of have a rough sketch of the graph. Okay. All right, so first thing that I want to do is I need to find the vertex. Now, it doesn't ask me to find the vertex as part of my problem, but the focus and the directrix will be found in reference to the vertex. So I first got to find the vertex. Okay. So the vertex here is going to be 10, -7. Right? Remember, the x is on the right-hand side this time, so got to take the opposite of this guy for the x-coordinate and the opposite of this guy for the y-coordinate. Okay, so that's the first step. The next step that I want to do is I have to find my p-value, because p is how far away from the vertex the focus and directrix are. So I need to find that distance. And remember that this guy right here, this is 4p. If you disregard the negative, right? So this just, negative means it's going to go to the left here. So we got to go 4p equals 12, right? So p is equal to 3. Divide both sides by 4. Okay, that's going to tell you how far away the vertex and directrix are. So that's a really important part. Okay, and then the next piece you need to find is the direction. And we already kind of talked about that. This is a y-squared parabola, which means it's either going to go left or right. And since this is a negative, it's actually going to go to the left. Okay. So here's the three things that I know about this from the focal form. And if we look back at our reference sheet, this is going to help us out. We have something like this, right? This one. The h and the k are the vertex. Remember, 4p, this number, is the focal width, and then p is the distance from vertex to focus, or from vertex to directrix. So we need all those three things. We also know that since we have a negative right here in front, it's going to be going left. So let's take those three pieces of information and let's just sketch out a graph. This is what I would do. So I'm going to come over here. Okay. So it doesn't have to be perfect. We're just going to get kind of a rough idea of how this looks. Okay. First thing I'm going to do is plot the vertex. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7. So there's the vertex. It's at 10, negative 7. Okay. The next thing I'm going to graph here is I'm going to graph the direction of the parabola. Now this doesn't have to be perfect because we're not asked to graph it. We just kind of need a sketch to figure out where all the pieces are. Okay, so this one we know is going to open to the left, right? So this is 10, negative 7. All right, so it's opening to the left. Now that means that my focus needs to be to the left, right? It has to be this way because the parabola is going to open around the focus. But how far to the left should I put the focus? 3 units to the left. Okay, so I got to go back. 1, 2, 3. So what are the coordinates of the focus now? Well, I was at 10, negative 7, but then I went back 3. So now I'm at 7, negative 7. Right? I just went backwards. Okay, so vertex is at 10, negative 7. I know the the focus is to the left, so I put it to the left. Okay, so that's one of the pieces we're looking for. The other thing I got to do is I got to find the directrix, right? Well, we know the directrix goes over here. It goes behind the vertex, and since this is opening to the right, we got to go to the left. And how far do we have to go to the left to where we put our directrix? 3 units again. So I got to go 1, 2, 3. So I was out at 10. Now I got 11, 12, 13. Okay. The equation for this line, since it's a vertical line, is x equals 13. It crosses the x-axis at 13. That's the equation. So here's the idea. This distance is p, which in this case is 3. This distance is also p, which in this case is 3. So if we have our vertex, and we know p, and we know the direction we're going, we can figure out where the focus and where the directrix are. Okay, so if I'm going back to my worksheet here, I know that the focus is at 7, negative 7, and I know that the equation for the directrix is x equals 13. Okay. So you're going to probably want to sketch out a graph. Now each of these is going to go in a different direction, so you have to be careful. You got this one is going to open up to the right because it's a y squared and this is positive. This one's going to obviously open up down because you have an x squared and then a negative. This one's going to open up. Okay, so right, down, up, that's a hint for you. Start with your vertex. You got to figure out your p value, and you got to figure out the direction. So for each of these problems, you need to find these 3 things. And then I would sketch out your parabola just on, you can use a scratch piece of paper or graph paper. You can even use Desmos if you want to throw it in Desmos and figure out where those things are. But you should be able to do this by hand as well. So don't like write the equation in and then figure out where they are. What you want to do is you want to use your algebra skills here, kind of. So on your test, you won't be able to use Desmos, obviously. All right, one more real quick. And this is going to be kind of similar, but backwards. Okay, so here I want to find the equation, but I'm given the vertex and the focus. Right, so here I want to find like focus and directrix. Here I'm given kind of those similar pieces, and I'm going to find the equation. So this problem set up here and this problem set are basically backwards. Okay, so let's go through this guy. What I'm going to do, the first thing I'm going to do again is I'm just going to graph it. Okay, I'm just going to do a little quick sketch. So get this guy back up here. Okay, so make a quick little axis here. And the vertex is at negative 9, 8. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. This doesn't have to be perfect. I just need to see some directions here. Okay, so this is negative 9, 8. Okay, that's the vertex. Okay, now the focus is at negative 9, 7.5. So negative 9, and then 1, 2, 3, 4, 5, 6, 7, but it's not quite to 8. It's like right here. Okay, focus. So what direction does this thing have to open then? It's got to open down, right? Because the parabola has to open around the focus. Okay, cool. So that's fine. Okay, how far away are these guys? They should be a half of a unit, right? Half of a unit. This one's up at 8. This one's down here at 7.5. So these are half a unit away. That means P is equal to 0.5. Right? The vertex and the focus are 0.5 away, or half of each other away. So why is this important? Well, the first thing we have to do is we have to figure out what direction this parabola is going to be opening. Because there are basically 4 different forms for a focal form that we could use, right? We need to know if the x is squared or if the y is squared. We need to know if we have a negative or a positive, that kind of thing. So since this is opening down, that tells me that I need to use a form that looks like this. X minus h squared equals negative 4p y minus k. Right? The fact that it's going down tells me 2 things. Number 1, it tells me that my x needs to be squared versus my y. It also tells me that I need a negative here so that it will open down. Okay. The other thing that we got from this graph is that the p is 0.5. The distance from vertex to focus is 0.5. Okay, so let's write that over here. We don't need this anymore. We got our direction. So p equals 0.5. Okay. That's going to go here. We also need h and k, right? Well, h and k are right here, the vertex. So once we have the form that we're using, like we know it's going to be focal form, but what I mean by that is the x squared or is the y squared, is it negative or is it positive? We've got to figure out the direction of our graph so we can write out a template for our equation. Once we have that template, we can fill in the h, the k, and the p. Okay, so we got p, we know that h is equal to negative 9, we know that k is equal to 8. So let's just throw everything in there. So x minus h, x minus h, x minus a negative 9, that's going to be x plus 9, right? Subtracting a negative number is going to turn into a plus there. Okay, then I have negative 4 times p. Well, that's negative 4 times a half, or negative 4 times 0.5. So that's negative 2, right? Okay. And then I'm going to have y minus k. So y minus 8. And that's it. That's my focal form. Okay. So I need to find the direction the parabola is going. That's really, really important. Got to find direction. I do that by just plotting these points just to figure out where it's going to go. Remember, the parabola has to open up around the focus. So that's how I knew this was going down. From there, that will give me the template that I need for my equation, whether it's a y squared or an x squared, whether it's a positive or negative, and then I just fill in my p, my h, and my k. Just one little quick note here. P was 0.5 here, and that ended up giving me like a negative 2 over here, which can happen sometimes. If you look back up at 16, there's a 2 right here, which means that P is going to be 0.5 for this problem as well. So you don't have to have whole number units between your vertex and your focus. It doesn't have to be like 4 or 1 or 2. It can be a half. So just wanted to point that out. Okay, that should help you get started on these. Follow those example problems to help you with the rest of them, but keep in mind that this one is going to open up down. This one could be open up left or right or up. So the directions might not be the same on all of these, so watch out for that. Okay, I hope that helps. Again, office hours are between 10 and 12, so if you need some help, hit me up. I've been doing a couple Google Hangouts video chats here and there, and I think those have been helpful for some students. So let me know if you need that. We can walk through a couple of these. Try to stay up to date, and yeah, keep in touch. Hope you guys are doing well out there. Thanks.